David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today we're going to have a second lesson on measures of dispersion. And to remind you of what that means, the measures of dispersion are talking about how far the data is spread out. So remember, our first few lessons were on central tendency, which is about how the data groups together towards a central point. And we had 3 measures to look at that. Now we're looking at data spread. Our last lesson talked about standard deviation, and that gave us one feeling for how far the data is spread out. Today we're going to talk about interquartile range. But I'd like to review a few points before we get started on that discussion. So, first off, these are our 4 measures of dispersion. Standard deviation, which is sigma. You're going to get introduced to a new one called variance, which is super simple. It's just sigma squared. And it's just another standard that people use to talk about data spread. Finally, there's range. Now, range is just the difference between the largest data value and the smallest data value. So the bigger the range, the more spread out your data will be. Finally, interquartile range. This is a little bit more complicated, but it's kind of like range, except that it has a nice feature of excluding the outliers, which, as we know from our last lesson, can skew the data one direction or another. So the interquartile range is just the third quartile minus the first quartile. And before we jump into that, the quartiles are pretty straightforward conceptually. You just take your data, organize it in order, and the first quartile is the first 25%, the second quartile is the second 25%, the third quartile is the third 25%, and then the last quartile is the remaining 25%. So the interquartile range is the value of the third quartile minus the first quartile. So it gives you a feeling for the range, but kind of like in the middle of the data. So let's take a look at that. Let's do an example that will help us show what the interquartile range is. So we're going to do this in a manual method, but just know your calculator will do this automatically for you. So again, make sure you know how to do the statistics functions on your calculator. So here's our data. We've got a bunch of biology exam scores. These are organized in order, which is the most helpful method for figuring out things like median and mode and stuff like that. So I've put them all here. I've got 22 terms, okay, pretty nice. Now, to start this, we need to find our median. So remember, our median is the middle value. It's the value for which all the data, half the data is above and half the data is below. So if I have 22 pieces of data, the median is going to be between the 11th and the 12th term. And so I've organized this with 11 terms on the top row and 11 terms on the bottom for our total of 22. So our median is right here. That's the median. And so what we do with that is we calculate the average of the terms adjacent, because I don't actually have a middle term. I have an even number of terms, so the median is going to occur between the two middle-ish terms. So it's going to be the average of 62 and 62. So we know here this data set has a median of 62. Okay, so to figure out the interquartile range, we have to figure out the values for the first quartile and the second quartile, or the third quartile, so that we can subtract the first from the third to get that special range that we're after. So first off, let's figure out the first quartile. This is the middle of the first half of the data. So we can look at this. We have 11 terms right here. So we have an odd number of terms, which means we're going to get a middle term in here. Now, you could just look at this and go, well, let's see. I have 5 here to get to 45, and then I have 5 here to get the rest of the way up to 62. So my first quartile is going to be the 46 right there. That's going to be my Q1. But there's also a formula that helps you do that. So if you want to do it that way, you can. What you do is you take your n, the number of terms for your first half. So that's n equals 11. And then you do n plus 1 over 2, which is going to be 12 over 2, which equals 6. So that means it's the 6th term, or the 6th data point. So then I could just go 1, 2, 3, 4, 5, 6, and that gives me my 46 as well, okay? So here we go, Q1 equals 46. Now I want you to pause the video and do the same thing for the second half, okay? I did the same thing for the second half of the data to find my Q3, and this data is all lined up nice on the page, so I can just go right to the 6th term in the second half and get 78 for my Q3 value. So 78 is the middle value in the upper half, which gives us the third quartile. So this is the third quartile, that's the fourth quartile, and of course this string data is the first and that's the second. So if you remember from the last board, the interquartile range is Q3 minus Q1. So that's what I've done here. IRQ, interquartile, oops, it's IQR. Let's get that right. IQR is 78 minus 46, or 32. Now that's a measure of the spread that excludes any outliers. Like you might consider maybe some of these scores to be outliers because they're so low, or you might consider these two scores to be outliers. So the interquartile range doesn't factor those in. It's just the middle of the second half minus the middle of the first half. So in some ways, this is a more stable representative measure of the spread of your data. Now finally, let's do the range. That's really quick. I want you to pause the video and do that calculation for me. Okay, range is just the maximum value minus the minimum value. So let's put that right here. I'm running out of space. Range equals max minus min, which then is going to equal my 98 minus my 18. 98 minus 18, which gives us a range of 80. So that's the range for this data. Let's manipulate our data points and see what happens. And this is going to give you the opportunity for some practice with your calculator. So first off, here's our test scores we used in the last example, and I just summarized all the stats that we can say about them. So there's our X bar, our mean, our median, our mode, our standard deviation, sigma, our sigma squared, the variance, and then our min, max, and the range, and the interquartile range. Okay, so now what I want you to do this in your calculator, is add 4 to each of the data points. So this one's going to become 22, this becomes 26, this becomes 30, and so on. So do that in your calculator, and then recalculate all of these values and write them down in the spot there. So go ahead and do that, and then come back and we'll see what you got. Let's see how you did. So when I went to my calculator and I added 4 to every data point in here, what I've got is my mean increased to 65.9, my median, my mode also increased. That makes sense because I just increased every value by 4. So these values just increased by 4, as did that one. Now, my standard deviation stayed the same. Now, think for a minute. Why would that be? Why wouldn't that increase? Well, it's because my data just shifted 4 higher. Every number is 4 higher. So the spread is still the same. It's still the same characteristics of the spread. So standard deviation and variance did not change. My min changed by 4. My max changed by 4. But how about my range? That stayed the same. It's still, from the min to the max, is still the same number, as is the interquartile range, because the Q1 and Q3 just increased by 4. So when you subtract Q1 from Q3, you're still going to get interquartile range of 32. Now, I'm not sure about your calculator, but my calculator doesn't give the interquartile range. It just gives the quartiles, which I can then use to calculate my range. One last exercise. Instead of adding 4 to each data point and comparing the new statistics with the original, with this data, now I want you to multiply each data point in here by 3. and then calculate your new stats. So you're going to multiply this 18 by 3, that becomes 54. That's your first data point. You'll multiply this 22 by 3, that's going to become 66. That's your data point, and so on. Get those in your calculator and then run your stats and write them down, and we'll come back and we'll talk about it. All right, let's see how you did. So now we're comparing our original stats to our stats where we multiplied all the data points by 3. We increased them by a factor of 3. So as expected, my mean increased by 3. Basically, we just multiplied this mean by 3 to get the new mean. That's not what we did. We calculated it based on our new data, but that's what ended up happening. Same thing with my median and my mode. They just got multiplied by 3. So we're at 186 for those. Now, check out my standard deviation. Unlike when we added a number to each database and the standard deviation stayed unchanged, the standard deviation got multiplied by 3 as well. So interesting difference there. And it makes sense because we multiply the bigger numbers in our data set by 3, so they go further away from the smaller numbers. So when you multiply every number in a data set by some constant, you're going to increase the spread of your data, and that's going to increase the standard deviation and the variance. The min and the max, all we did is we multiplied again by 3 to get our new values. So 18 times 3 gave us our new min, our new max. So our range also got multiplied by 3, as did our interquartile range. And I made that same mistake here. This is IQR. So there you have it. All right, let's summarize the results of that last somewhat complicated and long set of exercises there. So basically, if we have values for a data set like these are the ones that we've been exploring, and then we take some constant n and we add it to every value in that data set, what's going to happen is the mean is going to increase by n, so do the median and the mode. Standard deviation and variance will stay the same. The spread of the data does not change. The min and the max will increase by that same number, but the range and the interquartile range will stay the same. And the summary of that pretty clearly is that when you add a point or a value to every data point, some of the values change, like the measures of central tendency change, okay, because we've moved our data over by n, so all the central measurements are going to go over by n, so that's the plus n's on all of these. But the spread of the data stays the same. We just moved the data set over by n, so it's not narrower or wider, okay? And then it also follows that if we subtracted by n for every data point, the same thing would happen here. We'd get minus n for all the plus n's, and these would stay the same. Now, this is different when you multiply every data point by the same n. Now we are going to not only move the data down a bit, and we're also going to increase the spread of the data. So that's why in every case, except for variance, we multiply by n squared. In every case, we're going to multiply the original values by whatever that n is that we multiplied every data point by. Now, you might be asking, great, you did a bunch of math there and we found some relationships. How am I going to use this? So what you're going to see in the exercises and on the tests and quizzes is you're going to see some questions where you're going to need to use this information to answer them. Like one scenario might be that a teacher gives a test in a class and they want to curve it. So they want to increase the average by a certain amount. So they're going to tell you what the n might be. And it might be they want to increase the average by multiplying it by a number or adding a number to it. So that's one application of this concept. So be ready for that. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.